Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at the IPv6 Neighbor Discovery. We'll be discussing IPv6 Neighbor Discovery messages, and then we're going to take a look at the IPv6 Neighbor Discovery address resolution. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. When we're talking neighbor discovery, we're talking IP version 6. Now, IP version 6 neighbor discovery has three main types of messages. First type is IP version 6 neighbor solicitation and neighbor advertisement. What this is device-to-device messaging. IPM version 6 router solicitation and router advertisements, that's the second type of IP version 6 neighbor discovery messages. This is the messaging between devices and routers to figure out where the routers are and to understand that process. The last type of discovery message here is IPM version 6 redirect messages. What this is used by the routers to figure out what the next hop selection is. Basically calculate the best route to the destination. IP version 6 neighbor discovery address resolution. The overall concept here is PC1 wants to know whoever has this IP address, this IP version 6 address, send me your MAC address so I can get this frame delivered to you. It's a broadcast that goes out to everybody on my network. Hopefully the device that has that IP version 6 address replies back and says, hey, PC1, this is PC2, and this is my MAC address. Once PC1 gets that, we can finish building the frame and sending that data to the network interface. In this example, we're going to discuss the process in which IP version 6 does address resolution. We're going to use ICMP version 6 neighbor solicitation and neighbor advertisement messages. This is similar to the ARP process used by IP version 4, but has certain advantages we're going to discuss right here. Host A has a packet to send to host C. Host A is determined that the destination IP version 6 address is on the same network as host A. Host A knows the destination IP version 6 address, but needs the associated destination MAC address. We know the IP version 6 destination address from PCA. What we don't know is this MAC address right here. We don't know that MAC address. Once we get that destination MAC address, we can encapsulate it in an Ethernet frame and send it on to host A because it's on the same network. Host A examines its neighbor cache to see if there's an entry for this destination IP version 6 address. Similar to an ARP table, the IP version 6 neighbor cache maps IP version 6 addresses to MAC addresses. For simplicity's sake, we're just using 4 hexadecimals for the MAC address instead of the usual 12 hexadecimals. And examining the neighbor cache, we can see that there is no entry for our destination IP version 6 address. Because we have to figure out what the destination MAC address is, we put this IP version 6 packet on hold. I hope you're liking this episode on IPv6 neighbor discovery. If you have the time, please leave a comment and let me know what you think about the IPv6 neighbor discovery. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Host A creates an ICMP version 6 neighbor solicitation request. This is similar to an ARP request used for IP version 4 address resolution. One significant difference is ARP requests are sent directly over Ethernet. IP version 4 is not involved. The IP version 6 address resolution process uses ICMP version 6, which is then encapsulated in IP version 6 header, and then encapsulated in the layer 2 Ethernet header and trailer. The ICMP version 6 neighbor solicitation header includes the target IPv6 address, which is the same destination IPv6 address that is in the IPv6 packet. The IPv6 address is mapped to a special IPv6 solicited node multicast address, which is then mapped to a special Ethernet multicast MAC address. This mapping process contains a significant portion of the target IPv6 address. This allows for the Ethernet NICs on each device that receives this frame to determine whether or not to process the frame. This is where we see an advantage of ICMP version 6 Neighbor Discovery over ARP for IP version 4. Since ARP uses a broadcast address, all devices on the local network must at least partially process an ARP request. The ICMP version 6 neighbor solicitation message is forwarded by PCA. The switch will flood the Ethernet multicast frame out all ports except the incoming port. Host B receives the Ethernet frame. Host B's Ethernet NIC examines the destination MAC address. The Ethernet NIC will accept frames whose destination MAC address matches the MAC address on the NIC, is a broadcast MAC address, or a multicast MAC address that maps to one of the IPv6 addresses. In this case, the multicast MAC address does not match any of these. So host B's NIC ignores the rest of the frame without having to pass it up to upper level processes to make this determination. This is an advantage over ARP for IP version 4. Router 1 receives the forwarded frame in its interface. Similar process occurs on R1's interface. The Ethernet NIC ignores the frame because the destination multicast address to the MAC address does not map to any of the IP version 6 addresses. There is no match there. ICMP version 6 neighbor solicitation messages are not forwarded through the router. Just like ARP requests do not go through the router, these neighbor solicitation messages are not forwarded by the router. Another reason for this is because the solicited node multicast address is sent with a link local scope, which means it's only valid on the local area network. As soon as it goes through another router, it left the local network. So the router will not forward these requests. Host C receives the Ethernet frame. This time the Ethernet multicast MAC address matches a MAC address associated with host C. Specifically, the one mapped to host C's IPv6 solicited node multicast address. Therefore, host C accepts the frame and passes it up to its IPv6 process and then to its ICMP version 6 process. The target IPv6 address matches its own IPv6 address. That IP address is a global unicast IPv6 address. And now host C knows it is the target of this ICMP version 6 neighbor solicitation message. Before replying, host C adds the IPv6 address and the MAC address for host A into its own neighbor cache, and thereby letting it return a neighbor advertisement message to host A. Host A replies with a ICMP version 6 neighbor advertisement sent as an Ethernet unicast message directly to host A. The ICMP version 6 header includes the IP version 6 address, which host A already knew, and it includes the MAC address for host C. This target MAC address of host C, that's what host A was requesting to complete its IP packet encapsulation. Host A receives the Ethernet frame, examines the IP version 6 address, and MAC address in the IPv6 header and adds it to its neighbor cache. And now we can take the IPv6 packet off of hold. Host A updates the destination MAC address that is associated with the IPv6 address and forwards the frame and IPv6 packet to host C. If the IPv6 destination address was on a different network, the same process would occur to find the MAC address of the default gateway, which would map to R1's link local IPv6 address on this LAN. It was my pleasure to provide you with this wonderful episode on IPv6 Neighbor Discovery. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode on my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.